Today's lesson is about discrete random variable. A discrete random variable x has a set of distinct possible values. In this course, you will consider only a finite number of outcomes, so we label them x1, x2, until xn. For example, x could be number of houses in your neighborhood. To determine the value of discrete random variables, you need to count. Compared to discrete random variable, we have continuous random variable. A continuous random variable x could take possible values in some interval on the number line. For example, x could be height of each student in your school. To determine the value of continuous random variables, you need to measure. Guided practice 1. Classify the following random variables as continuous or discrete. Remember, discrete, you just need to count. For continuous, you need to measure. A. The quantity of fat in a sausage. This will be continuous. The mark out of 50 for a geography test. This will be discrete. The weight of a 17-year-old student. It's continuous. The volume of water in a cup of coffee, still continuous. The number of trout in a lake, it's discrete. The number of hairs in a cat, still discrete. The length of hairs on a horse, it's continuous. The height of a skyscraper, it's continuous. Let's talk about probability distributions. For any random variable, there is a corresponding probability distribution, which describes the probability that the variable will take any particular value. The probability that the variable x takes value x is denoted probability when x equals x. For example, when toasting 2 corns, the random variable x could be 0 heads, 1 head, or 2 heads. So, x equals 0, 1, or 2. We can use a table to show this situation. Possible outcomes. For the first and second coins, we have 2 heads, 1 head, 1 head, and 2 tails, or 0 heads. Therefore, for this x, you will get 2, 1, 1, 0. And this shows the probability value for x equals 0, x equals 1, and x equals 2. We also use a spike graph to show this probability distribution. The x-axis, we use number of heads, and the y-axis shows probability. So we have a value 0, 1, 2. We have the probability to show. Also, we use probability column graph. Using this, we have a value 0, 1, 2, and use this column graph to show the probability. Let's go to guided practice 2. A supermarket has 3 checkouts, A, B, and C. Management checks the weighing devices at each checkout. If a weighing device is accurate, a Y is recorded. Otherwise, N is recorded. The random variable being considered is the number of weighing devices which are accurate. A. Suppose x is the random variable. What value can x have? What value can x have? It will be 3. X equals 3, 2, 1, 0. Then for B, tabulate the possible outcomes and the corresponding values for x. We will make a table. We have A, B, C checkouts. All 3 accurate. So we have 3y. 2 accurate weights. Only 1 accurate weight. None of them. Then we can write down n like this. For this value x, this is 3, 2, 2, 2, 1, 1, 1, 0. So possibility x equals 0, you will get 1 over 8. Possibility x equals 1, 3 over 8. Possibility x equals 2, 3 over 8. Probability for x equals 3, 1 over 8. For C, describe using x the event of exactly 2 devices being accurate. That means the x equals 2. At least 2 devices being accurate, which means x equals 2 or x equals 3. When you're working on the probability x equals 2, it will be 3 over 8 from here. But for probability x equals 2 or x equals 3, that will be 1 over 8 plus 3 over 8 will be 1 over 2. Now let's talk about probability distribution. If x is a random variable with sample spaces x1 until xn, and a corresponding probability p1 until pn, so that the probability x equals xi equals pi, when I equals 1 through n, then here's the rule. This probability must be between 0 and 1 for all I. The sum of this probability equals 1. The set P1 until Pn describe the probability distribution of x. Guided practice 3. A bag contains 5 blue and 3 green tickets, and a number of tickets are randomly selected without replacement. We let x denote the number of blue tickets selected. Find the probability distribution of x if 2 tickets are randomly selected. Let's draw the tree diagram. For the B stand for the blue tickets, G stand for the green ticket. Blue ticket will be 5 over 8. This is 3 over 8. Then, since this is without replacement, it will be 4 over 7. 3 over 7. 3 over 8, then we got another green will be 2 over 7, so 5 over 7. Therefore, this will be 2 blue. 1 blue, and 1 blue, no blue. So we have x. This will be 2, 1, 1, 0. The probability will be 5/8 times 4/7 equals 5/14. For blue-green, you will get 5/8 times 3/7. That is 15/56. 3/8 times 5/7. Using these two, you will get 15/56. And 3/8 times 2/7, you will get 3/28. Therefore, for the probability of x equals 0, that is 3/28. Probability x equals 1. Since you have 15/56, therefore you have 15/28. We just multiply by 2. And a probability of x equals 2. You will get 5/14. Let's go to B. 3 tickets are randomly selected. This time, without tree diagram, I will show you how you get that. You need to pick up 3 tickets. The probability x equals 3. You need a blue, blue, blue. Therefore, you will have 5/8 times 4/7 times 3/6. You will get 5/28. Then we are looking for x equals 2, which means you have 2 blue. For the 2 blue, you will get 5/8 times 4/7. Then times green will be 3/6. This will be green. Then how many situations you have? It will be multiplied by 3. Therefore, your answer will be 15/28. Then probability when x equals 1 means we only have 1 blue. The other 2 are green. So we have 5/8 times 3/7 times 2/6. Then you will have 3 situations like this. Therefore, you multiply by 3. You will get 15/56. Then we go to probability x equals 0, which means you need to get all green. So you have 3/8 times 2/7 times 1/6. You will get 1/56. This will be the probability distribution when x equals 3, 2, 1, 0. Let's talk about another very important concept we call expectation. The expected outcome for the random variable x is the mean result mu. In general, the expectation of the random variable x is E of x equals mu equals this. Or you can write down this way. Suppose X represents the gain of a player from each game. Then the game is fair when expectation of a random variable X equals to 0. Let's go to guided practice 4. Find a K for the following probability distribution. Since this is the probability distribution, it will satisfy these three situations. The sum of all probability equals 1. Therefore, we plug in x equals 0 to this function. Then you will get k over 1. Probability x equals 1, you will get k over 2. Probability x equals 2, you will get k over 3. Probability x equals 3, you will get k over 4. Then all this adding will be equals to 1. In other words, I have k plus k over 2 plus k over 3 plus k over 4 equals to 1. So we get 25 over 12k equals to 1. And a k equals 12 over 25. For B, calculate the mu for this distribution. As we know, the mu equals expectation of x. That equals I from 0 to 3. xi pi. Before we plug in, let's work this out. This will be 12 over 25. This will be 6 over 25. This will be 4 over 25. And 3 over 25. Then we plug in. You will get 0 times 1225 plus 1 times 625 plus 2 times 425 plus 3 times 325. Add together, you will get, so you get the 23 over 25. Now let's go to number 2. A discrete random variable x has a probability distribution given by this formula. A. Find the probability x equals x for x equals 1, 2, and 3. Probability x equals 0. We just need to plug this here. So we get the k 1 over 3. 0, 2 over 3. 3 minus 0 equals. We just need to plug x equals 0, 1, 2, 3 into this formula. You will get this for the probability. For B, find k, hence find the probability x greater than equals to 2. Since this is a probability distribution, therefore, all the probability, it will be equals to 1. Therefore, I need to add all these 4 equals to 1. You will get denominator is 27. Top, this is 12k, 14k, 15k equals 1. So you have k equals 27 over 15. Then we need to plug in here for the k equals 27 over 15. You will get the 8 over 15. This one, 4 over 15. This one, that is 2 over 15. And 1 over 15. For the probability x greater than equals to 2, which means you need to add these two. Therefore, you will get 2 over 15 plus 1 over 15. That is 1 over 5. For C, calculate the mu. So mu equals xi pi, I from 0 to 3. Therefore, you will get 0 times 8 over 15 plus 1 times 4 over 15 plus 2 times 2 over 15 plus 3 times 1 over 15. So your answer equals 11 over 15.